this lesson, we're talking about the path of optimal value. When we want to find the path of optimal value, we're looking for the longest or the shortest path, either the maximum or the minimum, depending on the question, from one vertex to another. So think about it's building on the unit we previously did where we're discussing maximums or minimums, but we're doing algebraic solutions in different scenarios. On a graph without weighted edges, the path of minimum value between two vertices corresponds to the path that uses the fewest number of edges to connect those vertices. Conversely, a path of maximum value between two vertices means you're again following a simple path with no repeated edges that uses the most edges between those vertices. If, however, you've got a weighted graph, then the path of minimum value between the vertices corresponds to the path that has the smallest weight of all the edges between those vertices. And again, conversely, the maximum value between the two vertices is again the simple path with the largest weight of all the edges between those vertices. Let's look at an example. In the graph below, determine the path of minimum value and the path of maximum value with an initial vertex of A and a final vertex of F. I've included the definitions of maximum and minimum value as a reminder. So the first thing we're looking for is the minimum value. Starting at A, we can go A to B, to C, to D, to F. The length of that path is 4. There are 4 edges involved. However, if I go A to E, E to G, and G to F, I've got a shorter path with only 3 edges. So the path of minimum value is A, E, G, F. Now, how about the maximum value? Well, my first reaction was that the first path that I did of A, B, C, D, F was maybe the maximum. However, remember, the only requirement is that it's a simple path with no repeated edges. So that means I can go A to B, to C, back to E, to G. I can repeat vertices, so I can go to C again, just as long as I don't repeat an edge, and D to F. So by doing that, I get a much longer path, 1, 2, 3, 4, 5, 6, 7. So the path of maximum value is A, B, C, E, C, G, D, F. For part B of the question, now we've got a graph that looks the same, but this time we've added weights to each of the edges. So we're going to start off looking for the path of minimum value, again working with the same vertices of starting from A and ending at F. I'm going to start off going through what was previously the longest route. If I add up all of the edges, I've got 4 plus 1 is 5 plus 3 is 8 plus 4 is 12. Let's try a different route. AEGF. If we add up the weights, we've got 9 plus 8 is 17 plus 2 is 19. How about some of those zigzag routes that we did previously? AECGF. If we add up its weights, 9 plus 3 is 12, plus 4 is 16, plus 2 is 18. And one more zigzag route. ABCEGCDF. 4 plus 1 is 5, plus 3 is 8, plus 8 is 16, plus 4 is 20, plus 3 is 23, plus 4 is 27. Have I overlooked any routes? How about this one? A, B, C, G, F. 4 plus 1 is 5, plus 4 is 9, plus 2 is 11. At this point, I think I've exhausted all the possible alternative paths. There's one more path we'll try. AEG, CDF. 9 plus 8 is 17, plus 4 is 21, plus 3 is 24, plus 4 is 28. In my quest for the path of minimum value, since I think I've been through every possible alternative, I can look at ABCDF is 12, but ABCGF is only 11. That tells me I've got the path of minimum value. Now, since I've done all of the alternatives, I should be able to track down the path of maximum value fairly quickly as well. Taking a look at all the totals, it looks like AEGCDF at 28 is the largest. So to recap, for the path of maximum value, we look for the path that started at A and ended at F that gave us the largest value when we added up the weights of all the edges in the path without repeating any edge. Try this question on your own, then come back to look at the solution. In the graph below, the values represent the amount in thousands of dollars that a construction company must pay to transport its equipment from one city to another. Determine the minimum transportation cost from city A to city E. When I start looking for a graph, my first thought is this 50 seems kind of scary, so I'm going to try some other routes. I'm going to go A, G, F, D, and E. With that route, I've got 25, 50, 85. Let's try another route. A to D, 50 plus 35, actually comes out to be the same. ADE is also 85. How about AB, BD, DE? 25 plus 20 is 45, plus 35 is 80. And just to be sure that we've covered off all possible alternatives, we'll go A, C, B, D, E. 20, 15 is 35, plus 20 is 55, plus 35 is 90. So we can see that our minimum was A, B, D, E.